Okay, good morning, everyone that are joining for the keynote. So, the first keynote at the EuCNC and 60 Summit 2023 is by Magnus Frodigh, who is Vice President and Head of Ericsson Research. We will, after the presentation by Magnus, we will have the question and answer session. So you will see there are 6 microphones along the paths here. So go to one of those microphones if you're interested in asking a question. So we would appreciate that, and there will be this Q&A at the end. So with that, I would like to introduce Magnus Frodigh. Dr. Magnus Frodigh is Vice President and Head of Ericsson Research. In this role, he leads Ericsson's long-term technology research organization, its close collaboration with academia and industry, and its contributions to the Ericsson business and product development. He holds a Master of Science degree from Linköping University of Technology in Sweden, and a PhD in radio communication systems from the Royal Institute of Technology, where he is also adjunct professor in wireless infrastructures. He's a fellow of the Royal Swedish Academy of Engineering and Science, EVA. Frodigh joined Ericsson in 1994 and has, over the past 3 decades, held various senior positions within research and development and product management throughout the generations of mobile technology, from 2G and all the way to current research on 6G technologies. Magnus is also an innovator, and he holds 29 patents so far. So with no further ado, Magnus, I'm happy to welcome you again upstage.
Yeah, thank you.
The floor is all yours, the clicker is yours, the audience is yours, both here and online. And I will come up next to you during the Q&A session and help to moderate.
Thank you.
Welcome.
So, shifting gear from opening to presentation here on the vision on the future of technology and 6G then in particular. So let's see if we get this started. And I think there is, of course, always now in these early days, what will 6G be, what kind of role would it play, etc. And that's, of course, very difficult to answer, because we have been, during the previous generation, we have provided this platform which has enabled a lot of innovation. And we haven't really been able to foresee everything that's sort of taking off and how different applications are changing our lives, etc., on top of these platforms. I think 6G, if I now 7 years before it's being launched, they need to state what I believe it will be. I think it will play the absolute key role of connecting the cyber digital world and the physical world. And if you can connect these 2 worlds, there is a lot of applications that can be created on top of that. So that will be the theme of the talk here today. Before going to 6G, I guess we need to reflect a little bit on the development of 5G. And one thing we are fairly sure about is that our consumption of network data is increasing, and it continues to increase in this exponential way. And here we have the different technologies here. So we have the yellow, which is sort of the 4G, the 4G technologies peaking and then flattening out, and we have the growth on the orange, the 5G. And then on top of that, we are seeing a new business where the 5G technology is so strong and powerful that it can offer a fiber-like experience. So it's getting market share when it comes to the fixed wireless side. So it's being used for connectivity at homes as well. So this traffic growth is, of course, something that drives investment And the most efficient way for telecommunication operators to increase the capacity is to increase with new spectrum, new, more spectrum-efficient technology, and deploy that on existing sites. And that is how it's been traditionally been done, and now we're doing that for 5G as well. And the build-out of 5G networks is faster than 4G was, right? So it's the fastest growing technology that we have seen. And we see how, when you are installing the 5G networks, how traffic is moving over to the 5G networks. And everybody already has sort of 5G phones available, right? So it's a very strong migration and take-up of 5G. But this is one leg. The other leg is still in early phase. And this is this sort of using 5G for different industries. And we have been looking, for example, at smart manufacturing, the purple here on this list. And then in the graph there, you can see the expected sort of number of connected equipment, devices, sensors in smart manufacturing to create this digital factory of the future. And we are really still on a fairly flattish development there. And this is always the case, right, with this exponential development, that it looks a little bit linear in the beginning, and then sort of you really see how it explodes. So we haven't seen this yet, right? So this is a challenge that we have, that we are now trying to make a 6G technology that will sort of fit into the future where this blue curve has happened. So we need to imagine that we have the take-up that we have been planning for. We see all the signs of the different industries. There is devices coming. There are investments. We see how our sales is going up in this segment. There is huge investments, right? And all industries are creating digital twins of all of their products and services, etc. So there is a big momentum, but we are still in this early times. So when we talk about 6G, we need to take into account that we have seen now this digitalization going on broadly in the coming 7 years before we have sort of 6G on the market. So it's always tricky to think about step 2 when you haven't taken the first step, really. So this is a challenge, but we need to assume this. And the values and the potential of the different possible industries that can take advantage of this digitalization is, of course, huge. So the enabling technology and the enabled value of this sort of digitalization, I think there is no questions around that. So looking now at this 6G networks of the future in 2030, where we are connecting the cyber and physical worlds here. You saw the movie there in the opening, and that was really about this connecting the digital and the physical realities. In order to do that, you will need, of course, a lot of connectivity, and this is really our home turf. We have been working on this for previous generations, and there's a lot of research now. I will show a little bit of it later, where we are enhancing, we are adding new capabilities, and we are really pushing forward then on this use of this technology and the further evolution and so on. The trustworthiness is something which comes with more and more importance. It's not only of encrypting data and protecting identities. It's about really providing these resilient and robust networks where you can sort of use them for mission-critical, life-depending type of applications. So if you want to realize the scenario with the connected bus and the bicycle there, you realize that you need a very, very robust system, of course, in order to run such applications. So here I think we will make quite a lot of progress compared to 5G when we go to 6G. I think we made it quite a lot in 5G when it comes to providing sort of ultra low latency and robustness. But I think we need to build that in much more on lower layers when we look at 60. So you need to have that already in the physical layer, multiple connections, and so on, right? Then the cognitive part, and I think this is really something that are feeding this sort of digital representation on top of these networks. We need to have sort of data out of the network in order to get metadata around the communications that we are providing. It could be, of course, positioning, it could be time information, but it could be predictions on the future network connectivity, etc. And joint communication and sensing information should then be provided upwards. So this is of importance in order to build all the applications on top of this digital representation. But of course, the network in itself should take advantage of all of this sort of data around its setup, its performance, and how it can adjust to changing demands. Because the requirements on these networks will go beyond sort of best effort type of services, which is dominating today, where a short glitch in communication might not be that big of a deal. But now it's so much more important to have sort of the possibility to make this assurance of your provided communication, and by that you need to be data-driven. You need to have the observability and everything in place. And the complexity will continue to go up, and we need to hide that complexity within the network by making the network in itself more data-driven and autonomous. Then finally, these applications that we are foreseeing, to really make them real-time and low latency, you also need to have the compute and the application close to the action. If there's this traffic crossing you want to control or something, you can't have the data center too far away, right? So there is a need to be able to move the compute between the central, the edge, and the device. And in order to do that, you really see that you need to merge the connectivity and the compute networks into one coordinated infrastructure. So we talk about this network compute fabric. Given all of this, we should be able then to provide this fully digital representation of the different environments. We should be able to do the simulation, location, and mapping type of applications in order to provide then the base for applications on top of this. And here we need to think about how we can use these applications in a way so we can have multiple operators, multiple vendors, to get this fully interoperability between both the infrastructure vendor, the operator, the compute provider, the application provider. So we need APIs on top of this digital representation where you can sort of access both, put your user data, the data around the application, the compute, etc. Everything needs to be integrated so you can create these applications on top. And then you can do this Internet of Senses type of applications. You could sort of get the digitalization and programmability. You can have the connected machines on top of that. And I haven't talked so much about it now, but there is sort of obviously everything we do is now driven by the sustainability investment and angle and requirements. So of course the network itself needs to be more resource efficient in all possible ways, but the enablement of doing things in society in a more optimized way as of course a good first start in reducing our CO2 footprint. And if you completely change the way you do things, you can drastically change, of course, the footprint we have. And this digital moving things from sort of physical products and things into digital is of course one way of reducing the environmental footprint of our society. So looking a little bit into this, the connecting the cyber and physical worlds. So in the physical world, we will have that filled with sensors. So all of this information needs to be moved over to the digital, right? In this digital side, you will have this real-time sort of digital representation. Then you will have different objects in the physical. They will have their digital twin then, real-time updated, also living in this digital representation. And if you have that full digital understanding of the scene, the things that you would like to control, etc., then of course you can make applications on that side. And you can of course go back and see what went wrong. You can also look forward and predict. You can have, since you have a fully digital model, you can also simulate different actions, and you can select the one that leads to the outcome that you would like to see, and then you can program that back, send that information back to the physical actuators, and in that way you can build these cyber-physical connections. So this is really the key. And the good news is that we can do this on top of 5G. So all of this needs to be started, established, explored. Ecosystem needs to be created. So we have this uptake of this digitalization from now on, building on the 5G networks that is being rolled out, has been rolled out. So we have an enormous opportunity here to really use the networks we have, right? So this is the most important, I think. Then, of course, we will learn, so we will see the limitations. In a way, this is the first generation when it comes to connected machines, etc., right? So of course, there will be features needed, capacity needed that we have not yet planned for. So the need for 6G will grow over this time. And then in parallel here, we are now, of course, starting up the 6G work, and we know it's a long process. It takes time to create these technologies. So if you look a little bit into the 6G time frame, we are now at 2023, so we are in the middle of this sort of basic research. We have done the first projects together. We have been running research in the universities. We have been working in the industry, etc., exploring different technologies. Now we are in a phase to put together all of these different things into something that can give the desired performance. So that's a very exciting phase. And then, of course, this is not sort of final when it comes to basic things. We will gradually bring in new technologies into 6G, of course. But we have the first systemization phase going on now, which is very interesting. And then hopefully we can get a little bit on that, so we have a preliminary view on that, and then we will open up in standardization, and we start with the study items and the work items, etc. And then at the parallel, we will also see different test beds and trials going on, showing the potential of the technology. And then we are aiming to get the commercial products here in the 2030 timeframe. So this is all good, right? And spectrum is also being on the agenda here. I will return to that. But we have 2023 now. We had a World Radio Conference. And 2027, we had a World Radio Conference that hopefully then can identify and take decisions on spectrum that we can make available then for 6G networks. Before going into some specific ideas, I would like to reflect a little bit on this, the need when it comes to 6G and the capabilities then we would like to have. I think previously we have been very much looking at the capacity, the coverage, the data rate, etc. And now we had the latency and the positioning, etc. in 5G on top of that. 5G really made huge advancements when it comes to energy efficiency. So that there we have done a lot. But now the target that we have in front of us is more complex. And we have efficiency there in the center. We have secure, more highlighted, and sustainability. So to take the energy efficiency of the technology and the enabling capabilities even further. So this is really at the core. Then, of course, we have this outer ring there with things like the sensing. Can we use the network for sensing? I think that's very interesting. We have the relation with the dependable compute and the AI algorithms. I think we have increased flexibility of the standard when it comes to deployment, but in practice it's very much large macro cells providing coverage today, which is dominating the deployments. And I think we need to see a richer way of building these networks in the future. And in order for that to happen, we need to provide even more cost-efficient way of doing that, of course. So there is a lot of additional requirements in order to build this 6G network platform that really can enable these applications. And it will not be enough you are taking a Netflix movie over here, sending that over here. It will be much more demanding in order to provide these real-time applications and to provide both connectivity, compute, security, and data around it. So we really need to think broader. And this is to me what makes the 6G even more sort of interesting, right? So going into a few details, let me talk a little bit about spectrum. Spectrum is of course always key, and we have seen how the 3.5 spectrum has really been the engine of providing high capacity for 5G networks now. We really like to have more spectrum, of course, in as low as possible range in order to continue this. So we have talking about this centimeter range there, 7 to 20, 7 to 15 gigahertz. On this band, we believe that we can use this technology and reuse sites and still provide good coverage on these frequency bands. Then we are also going even higher. So there is this sub-terahertz where you can have then an extremely large bandwidth, of course, but of course the propagation will be a challenge there. To illustrate this and to use it is always a need to look at this, that you use this combination of frequencies. Just using one single frequency for a network is not a good idea. You need to combine them. So you take if you have high capacity users which are in a good spot, of course, you should take them with the highest frequency you have available and offload that so you can use your lower frequencies for the ones that are around the corner and indoor and a little bit further difficult places. So I have an illustration here on combining the two green ones here. Before that, on the sub-terahertz, we show now in Barcelona this year at the Mobile World Congress, a demo there of 100 gigabits, still over a cable, but with all the digital parts on both transmitter and receiver on these bands. So obviously it's possible to build the communication networks providing 100 gig data rate. The question is, of course, what kind of coverage, etc., you can expect. And it could, of course, be on extreme situations where you would like to have sort of in a stadium or in a conference hall like this, everybody would like to have their own sort of augmented reality experience of this session, etc., looking at all the virtual objects I have here around me, etc. So that will, of course, be one case. But it's also like this, that you can have a centimeter here deployment, providing then sort of 10 gigabit or something. And then if I click once more, I think both of these will move exactly. But then, of course, you can provide even higher capacity to the outdoor users in this red area. So still, even in a normal deployment of today, in an industrial area, in this case it's a model of Kista here, where we have our headquarters, you can have quite a lot of traffic taken up by the terahertz band as well. So you shouldn't just put it as a niche. It could be used, of course, in combination with other bands. But it's really the centimeter that will provide the capacity that will move the needle compared to today's networks. Then looking at another extreme, if this was sort of the terahertz, this is sort of the opposite, you can say. How can you build sensors which are zero power, almost zero costs? And how many sensors could you have in a jacket like this? And what could you use it for? So we are doing this together with MIT. They have created a thread, a metal thread, or a thread with metal in it. And they can create this fabric, and then you get a pressure sensor for each of the crossing of these threads. And then you can connect all of that, and then you can get the data out of that by training it like this. And the trick here is really the enormous amount of sensor information. That could, of course, look noisy, but if you feed that into an AI algorithm, which has sort of the ground truth, you can start to predict what the person doing just by looking at the sensors from the socks. So it's amazing, and I think this is just an example of what we can do when we have this surplus, enormous amount of sensors being connected and able to take that data and use that in order to predict and understand what is happening in different scenarios. So this was a little bit around the sensing. Then, of course, this will need to be connected, and you can't have batteries and everything, right? So you need really to go for extreme low power consumption, and you need to do some energy harvesting. And we have really stretched it to the extreme here, and we have designed this harvesting device in order to collect enough energy in order to do some processing and to transmit messages then from the sensors. And we have done this before. We have a huge set now of technologies, right? So we have the NR, the 5G. Then we are in the standard have done the reduced capabilities, or RedCap, going down in order to make a little bit simpler 5G devices, but still very capable. Then we have from 4G times the LTE-M and the narrowband IoT. But this one, we are really placing there even further down when it comes to even less capabilities, but then very, very low energy consumption, and even so low that you don't need to have a battery, right? Or you don't need to change the battery. And of course, this opens up a lot of different use cases. You can have these on-body trackers, you can fill different environments with sensing, etc. And you can have these plants, and it is just enormous what kind of values. And you get report these days from different farmers, have digitalized part of their farm, etc. And they are reporting back that, 20% gain is possible straight off, right? And if you then completely change ways of doing things, the gains are even larger. So this is exactly the potential that we need to use when it comes to using our technology in order to address the challenges we have in front of us. Finally, I would like to talk a little bit about JCAS, Joint Communication and Sensing. And here, of course, you can think about like a radar system. You send out the pulse and get it back, right? But within our networks, we can, of course, we have a huge infrastructure which we can reuse. So we can have some base station transmitting, some base station receiving, we can use the devices, etc., in different combinations. If we are working on lower frequencies, then, of course, we get a better range, better coverage. If we do go on extremely high frequencies, then we can get up a higher accuracy. And to illustrate this, we have made this small lab experiment. So this is a room where we have a transmitter and a receiver. And the importance here is that the receiver can, of course, detect when the signal comes from different reflections, and then at what angle. So by the time difference, of course, you get sort of the distance, which is on an elliptic form, right? And then with the receiver, on the angle of that gives you a point on that ellipse. And then you can do this and follow the different responses then from the different objects that you get in when you do this sort of frequency sounding in this area. And it could look then something like this. This is a room, you get different reflections, and you can see there how different objects can be detected by these clear reflections coming in, and in what angle they are coming in this antenna array. So it's obviously possible to make a joint communication and sensing by using our technology in order to get sort of the information around. And I know there's a lot of research going on here. There are demos outside in the exhibition hall on this, etc. So please engage and ask more questions to the ones presenting out there. So ending up with a little bit of advertisements here. So on the Ericsson booth outside in the exhibition hall, you can see these zero energy devices I talked about. You can see the sort of non-terrestrial application, that the satellite piece, the holographic communication we are showing, digital twin of the 6G network. We have this multi-robot sort of exploration here just outside in the lobby. And you should also go to the HexaX. Project is in its final phase, and we are able there together with our partners in the project to show very interesting demos there as well. There is something on the waveforms. We have the joint communication and sensing demo over there. There's the data-driven piece, collaborative robots there as well, explainable AI, and all of these different topologies to make the systems work in different sort of emergency situations, etc. So by that, I would like to conclude, and I really see that 6G will enable this cyber-physical world. There is a rich set of possibilities in front of us. And I think we will be all surprised what the different innovation and application that will be created on top. And there is a lot of work to be done, and I hope that you all are interested in contributing in driving this technology forward. Thank you very much.
Okay, so it's time to start the Q&A part. I hope we have you slept well, you are eager to ask questions. So as I mentioned in the beginning, there are 6 microphones along the paths here, so please go to a microphone. We have first question over there, yes.
Thank you. Joseph Noll from the University of Oslo and the Basic Internet Foundation. I've seen that you are still extremely keen on technology, whereas the sustainability of giving access to information for every single person on this world isn't mentioned neither in your 5G evolution and your 6G evolution. And looking into Africa, where like south of Sahara, 40% are not connected, schools are not connected. Where is the vision of of coverage and connecting the unconnected?
Yeah, thank you. There were a little bit multiple questions there, right? I think when it comes to providing technology to unconnected areas, sometimes it could be a question about technology. But typically, it's more of a difficulty to have investment in the technology, building the networks. The technology is available. I think with the integration of satellite communication and the promise of more efficient and lower cost satellite communication, backhaul down to these different places will be possible. And that has the potential of lowering cost and making the technology available in even more areas of the world. So I sympathize with your comment there, but it's not only sort of a technical type of question, right?
I would tend to disagree, because like in 4G, we have extended cells. We have demonstrated in Norway that we can reach out to boats 120 kilometers. In 5G, the coverage is bad. And we could use the multi-MIMO technology in 5G for large cells to actually reach out to rural schools in Africa.
Yeah, you can a little bit extend coverage. I agree, and I think we have these technologies available. And I think then also, of course, to really get out to areas which is not on the border of the current sort of networks, you really need to take multiple hops or really into different places when you have connectivity today. Of course, then satellites is an interesting option. Then I think you also addressed the energy efficiency, and I didn't talk so much about it, but the 5G networks have the potential to really, really reduce energy consumption, because they are built in a way so you can have them in sleep mode when they are not sort of transmitting, right? Or when there is no sort of communication going on in the cells. And by doing that, it is possible to build denser and denser networks and lower the needed energy for the communication, but keeping sort of this background use of energy down. And of course, adding one system is not solving it, but if you are adding 5G, moving traffic from older generations into 5G and can able to turn off older equipment, there is a huge saving. So I think we have been addressing that, and we will continue to address that going forward, definitely. Thank you.
Please.
My name is Toon from TNO. We just talked about 6G for, let's say, rural areas, but how do you see the role of 6G for providing more indoor coverage? We see a lot of data actually being generated from indoors, from this kind of environments, from homes. That's where people are sitting when they're with their tablets and using a lot of data. Is 6G going to do this, or what's the role of Wi-Fi in this?
Yeah. On the 5G side, I think we all see now that our phones are connected to 5G when we are outdoor and indoor, right? And that's happening in the good old way that you are connecting to outdoor base stations still. I think we have higher frequencies also for 5G, and there is a possibility to build this millimeter wave type of networks, which will be perfect for indoor locations. We haven't seen that taking off yet. As I said, it's very much traditional large base stations, which is still the dominant way of building networks. I think we have technology available, and I think we are seeing it taking off more when it comes to deployment in factories, etc., where the factory owner can take the investment and the value generated by providing this dedicated and very sort of capable communication easily could be return on investment on these cases, right? So there you have market starting, and we are seeing how the radio dot system that we have are taking market, and we also see our competitors are gaining market here, and so it is happening on the industrial side on these dedicated indoor networks. I really hope that we can also see that in more public areas as well, of course. Not yet sort of taking off. And again, now we are planning, talking about 6G. I don't think 6G will magically solve this. That this needs to be solved now based on 5G. And then 6G will kick in to provide even higher capacity if everybody in these indoor areas would like to have these augmented reality services, etc., to provide that high capacity. Thank you.
More questions? Please, Stefano.
Hi, my name is Stefano Buzzi. I'm from the University of Cassino, Italy. Okay, regarding ISAC, Integrated Sensing and Communications, do you see as a potential use case also for operators the surveillance of our skies in urban areas. So if you imagine of a futuristic scenario where we have UAV flying taxis and so on, using the communication infrastructure, so the base stations acting also as radars, this could permit having this control of the areas and provide new business opportunities. What do you think about this scenario?
Yeah, I think that sounds like one very, very suitable scenario for using this technology. It was most likely the reflections that you will get more clear, and since they are objects quite separated, that will reflect back. So yes, I think it could definitely be used for that. Yes.
Thank you.
More questions? Yes, please.
Thank you very much for your presentation, and very inspiring. And so I listened carefully, right? So in order to connect the digital world and the physical one, so you get some data, some information, but later you need to make some decision and act on those. So all of them actually require somehow computing capabilities built in the network. So the computing could be provided in an end device like cell phone or just a machine or node, or could be provided in a core network here. So I'm wondering, and to the best of your knowledge, right, how should we balance, leverage, and distribute such computing capability? Moreover, for the standards body like 3GPP or somewhere else, should they standardize such computing capabilities? Right now, people are talking about like hertz, terahertz, all those kind of things. Those are bandwidth related. But in order to implement applications, somehow we need to put everything you are talking about in a, somehow in a standards roadmap. Thank you.
Yeah, thanks for the question. There is now, this is a key question, how this compute and communication will evolve together. I think today we have the sort of the applications being done in some central data center and sort of run on the device. That's what's happening today, and that business model will of course continue. I think there are different things than breaking that, and the real-time requirements moves compute further down in the network. And then, of course, the hyperscalers and other compute providers will build more and closer. So they will be able to have their compute closer and closer. But then you would need to have places where you have compute and connections to all the different operator networks in a fairly distributed way. So here I think standardization could come in play, and how you should then be able to, together with the connectivity and the compute, what kind of values you will be able to expose to applications. Another force that drives something different is that the devices are not able to handle all the compute they would like to do. So they need to offload compute to the network or to the data centers or the edge data centers or something like that. So that's another driving force. And then, of course, you would like not to offload it too far away if you are really working on time-critical communications. So there is a lot of forces speaking for that. Yes, there will be compute in the network or data centers, edge data centers, which are sort of connected together with the network. And it's really an open question on exactly how this would look like. So this will be exciting to follow and see how it develops.
Thank you very much. But you haven't talked about that, the roadmap of such computing capabilities in a standards body like 3GPP, if that's needed, right? So Ericsson, as a major vendor, maybe could do something here. I'm not sure, like maybe currently in 3GPP roadmap, there are already a working group talking about this, right? Such as, for example, API, like related to computing, that kind of thing. So right now, in all the like documents and, I read. So there's nothing talking about those because, they are only talking about connection, right? Here, in order to connect digital one and the physical one together, we need probably more intelligent computing, that kind of thing. So that's something I just like to know your opinion about it. Not definitely final answer, definite answer.
Yeah, I don't know the answer on this one, right? But I think we need to take some steps. It needs to be a build out of this infrastructure, and I think we are seeing how hyperscalers are building out their networks to all countries, to all major cities, and further out into sort of all cities, basically, right? So there is a build out of compute. And this is a huge investment, and it takes time, and you can see how that could go even further, and you can have compute, perhaps not at every base station, but in areas where we have base stations. So this is, of course, happening. But there's also this accessibility of the connectivity, and if you would like to have these connections between multiple different objects that you would like to control, they happen to be on different operators, etc. You need also the APIs on top of the network. So I think there are steps that we need to take before we will see the fully network compute fabric. So we need to see how the compute is more distributed compute is being built out, and we would like to see how the APIs out of the network is being developed, where you can access more sort of quality of service network slices with different characteristics, and you can do this cross multiple operators, etc. So there are a few steps at least before we get to this fully network fabric that we need to explore first. And when we have done that, I think perhaps the second question here will be clearer.
Okay. I think we can take one more short question. Then we need time for the coffee break. And there are two speakers in the speakers' corner, also doing coffee break, starting 10:40. So let's one short question, please.
Thank you very much for this presentation and for sharing your ideas. One of the things that you spoke about. Sorry, my name is Ashwini Bihari, and I'm from the Satellite Applications Catapult in the UK. So you spoke about reach, resilience, robustness, and the sustainability aspects. And many of these goals, in order to achieve them, relies on the convergence of, as we know, terrestrial and non-terrestrial networks. And I would like to hear from Ericsson's perspective, what are you working on proactively to drive this convergence? Because very often we see it's almost like a wait-and-see game. Let's see if satellite communication is going to become cheaper, more accessible, but the industry is fragmented as we know it. So I'd like to hear your views on that.
Yeah, I think we're doing many things here, and we do see a market opportunity in this as well. I don't think we are planning to build satellites or electronics that will be on the satellite, but there's a lot of equipment on the ground that we are ready to provide and compete with. What we are doing is that we are driving POCs together with other industry players in order to verify the link budgets and how many megabits you can get in different conditions using a smartphone then to connect with satellites. I think that's important to verify and make to prove the performance. And then we are driving the adjustments of the 5G technology in 3GPP, right? With how to adjust with all the Doppler shifts and following satellites and all of this fine-tuning that is needed to optimize performance. So these are two very concrete contributions from our side. Thank you.
Thank you.
Okay, so I think it's time to conclude Keynote 1. Let's give Magnus a big applause. And also to all of you being active questions. So have another gift for you,
Okay.
Magnus. It's another color this time.
I have someone for my wife as well then.
Yes.
Yeah, thank you.
Thank you very much.
Yeah, thank you very much.
So then it is coffee break, 10:40. There will be speakers in the speakers' corner. It's in the upper left part of the exhibition area. 14 hours, we have the next plenary event, plenary one.